So Unit 2 first day lesson is a review of things we already know. So this I'm hoping will be easy for you. So Unit 2, the first section is going to be focused on radicals. You can see in the left column, there's a part 1, 2, 3. So part 1, we're going to focus on radicals, part 2 on rationals, and then part 3 on polynomials. So today is an overview reminder of what we did in Unit 1. Our base function for a radical is always square root x. We know that the intercept for this is at 0 for the x-intercept and y equals 0 for the y-intercept as well, meaning that our graph starts at the point 0, 0. Because we have a square root function, we also know that we cannot have negative numbers in here, so it must be greater than 0, which is what makes up our domain. So for the base function, our domain has to be greater than 0 or equal to 0, I guess. It's okay if it is 0. And because of the way that the function is set up, the square root of a positive number is also going to be a positive number, so the range of the base function is greater than 0. These are things that I'm expecting you to know from memory about the square root function. You should know the x and y intercept, you should know the domain and range, and you should know the basic shape. I would also add here that I want you to know at least 3 key points. And again, we're always going to choose points that are easy to calculate. 0, 0, 1, 1, 4, 2, 9, 3. I want you to also notice that there's an arrow at the end of this graph, meaning that it goes on and on and on forever into infinity. We can choose an infinite number of positive values of x's to put into this graph, and it will give us a y value. So our end point at the beginning is at 0, 0, but there is no end point as it goes off into infinity. When we transform the graph, this is from Unit 1, we have parameters that tell us what to do with the graph. And it gives you a summary of those parameters in the bottom here. If we have an A out front, then we are looking at a stretch. If A is less than 0, what's another way to say that? A number less than 0 is what kind of a number? It's a negative number. So if A is negative, then we have a reflection over the x-axis, right? So A less than 0, meaning it's negative, we have a reflection over the x-axis. The other thing I want to remind you of, if A is greater than 1, so it's bigger than 1, what kind of a stretch is this? An expansion. It's getting bigger. If A is somewhere between 0 and 1, meaning it's less than 1 but greater than 0, what does that mean? Compression. It's getting smaller. So if we have a small fraction, we are squeezing it down shorter. If we have a large number, we are expanding it taller. If it's negative, then we flip it. Similarly, if we have B is inside of the bracket, inside of the radical, but outside of the bracket. This represents a horizontal stretch, and the same rules apply. B less than 0 means we have a reflection over the y-axis, right? So if B is negative, then we have a reflection over the y-axis. The factors now are going to look different. If we have a B value between 0 and 1, so it looks like a fraction under the radical, what do we call that? An expansion, right? X is always doing the backwards thing. And then if B is greater than 1, we have a compression. And then H represents a horizontal translation. When we see a negative in front of the H, that means, again, we're doing the opposite. We are going to the right. And if we see a positive in front of it, we are going to the left. Now, one of the things that we're going to ask in the next example here is if we have something like x plus 3. That tells me that the H is negative 3. Right? Because when I put it in to the base function says x minus h. So if I put it in, stop.